another interesting maths class. My name is Manuela Ndiomu, and today I'll be taking you on the topic Multiplication and Division of Directed Numbers Part 2 under the theme Basic Operations. Now, before we go into this class, let's take a look at the objectives of this class. Now, by the end of this lesson, you should be able to obtain the square roots of numbers, and you should be able to obtain the square and square roots of given numbers from the table. Now, in the previous part of this class, if you recall, we learned about directed numbers. We learned that directed numbers are positive and negative numbers. We learned where they lie on the number line. We also went on to learn about squares and squares of numbers and how they are always positive numbers and never negative numbers. We went on to learn about perfect squares as well. Now, in this class, we'll be learning about square roots, and we'll also learn about square and square root tables. Now, let's start with knowing what a square root is. A square root is a factor of a number that when multiplied by itself, it gives us that same number. Now, let's look at the number 16. What are the factors of 16? We have 1, 2, 4, 8, and 16. Now, the square root of 16 will be 4 because 4 is a factor of 16, and when multiplied by itself, it will give us 16. Now, another example is that the square root of 25 is 5, and that is because 5 is a factor of the number 25, and when 5 is multiplied by itself, it will give us 25. Now, we write square roots as this. You can see from here that the square root of 64 is 8. Now, to make it simpler for us, square root is the reverse of a square. So just as we have the square root of 64 to be 8, the square of 8 is 64. Now, if you remember in the part 1 of this topic, when we were talking about squares, we said that a negative number cannot be a square. So this means that we cannot find the square root of a negative number. And this is because there is no number that we can multiply by itself to give us a negative number. Now, let's look at the square root of minus 9. This doesn't exist because 3 times 3 is equal to 9, and minus 3 multiplied by minus 3 is equal to 9. So the square root of minus 9 is not equal to 3, and the square root of minus 9 is not equal to minus 3. Now, if you look at the example given in the previous slide, you will see that a square has 2 square roots. The square root of 9 is either 3 or minus 3. So when we are asked for the square root of a number, we have to give the two numbers. So the square root of 9 will be plus or minus 3. Or we can look at this example that the square root of 25 is plus or minus 5. This is the sign we use to represent plus or minus. So from these two examples, you can see that the square root of 36 is plus or minus 6. The square root of 16 is plus or minus 4. Now let's look at an example. Find the square root of 3 whole numbers 6 over 25. Step 1. We write our mixed fraction as an improper fraction. 3 whole numbers 6 over 25 will give us 81 over 25. Step 2. We write both the numerator and the denominator as a product of their prime factors. The product of the prime factors of 81 is 3 square multiplied by 3 square, and the product of the prime factors of 25 is 5 square. Now we find the square roots of the numerator and the denominator separately, and we write a plus or minus sign before the answer. Now we find the square roots of the numerator and the denominator separately. Now, since square root and square are the reverse of each other, the square root here will cancel the squares here to give us 3 multiplied by 3, and the square root here will cancel the square to give us 5. 3 multiplied by 3 is 9, and we have 5. So the square root of 3 whole numbers 6 over 25 will be plus or minus 9 over 5. So just to add, this table here shows us the numbers from 1 to 900 that are perfect squares. This will easily help you to find the square root of numbers and the squares of numbers. Now let's go on to talk about square and square root tables. Now, when finding the square and square roots of numbers, we can use our calculator or we can use what we call a 4-figure table. Now, a four-figure table is a mathematical table that shows the results of certain calculations. It is called a four-figure table because all the results are rounded up to 4 significant figures. This is what a four-figure table looks like. Now, a four-figure table is very useful when we are finding the square or square root of a decimal number. Let's look at the table given to us. We will use this table to learn how to find the square of decimal numbers. This table is a square table that shows the squares of numbers from 1.0 to 9.9. Now let's look at an example. Using the square table given, find the square of 7.2. Now let's look at our table. We have the left-hand column and we have our top row. Now 7 is the number before the decimal point, so we look for 7 on the left-hand column of the table. We have 7 here. Next, we have 0.2. So we look at the top row for the column headed 0.2, which is here. Now we look for the number that is across from 7 and under 0.2. We have the number 51.84. So the square of 7.2 is 51.84. Having looked at a square table, let's go on to look at a square root table. Now this table here is a square root table that shows the square root of numbers from 10.0 to 19.9. Now let's look at an example. Now use the square root table to find the square root of the following numbers. A, 14.8, B, 10.5. Now we have 14.8. Just like we did in the square table, 14 is the number before the point. So we look for 14 on the left-hand column of the table, which is here. And the next number is 8. So we look for 8 on the top row of the table. Now we look for the number across 14 and under 8, which is 3.85. So the square root of 14.8 is 3.85. Our next number is 10.5. We look for 10 on the left-hand side of the table, and we look for 5 at the top row of the table. Now we search for the number across 10 and under 5, which is 3.24. So the square root of 10.5 is 3.24. Now it's time for you to do it yourself. Do well to pause this video and solve this exercise. I'm sure you're done. Now using your four-figure table, number 1, 85.3 square is 727.6. Number 2, 12.8 square is 163.8. Number 3, the square root of 45.2 is 6.723. And number 4, the square root of 15.4 is 3.924. If these were your answers, you are correct. Now, having solved those, we have come to the end of today's class. But before we go, let's take a look at a quick summary of all that we have learned so far. We learned that a square root is a factor of a number that when multiplied by itself, it gives the number. We also learned that a square root is the reverse of a square. Going on, we learned that a negative number cannot be a square. Next, we learned that you can use a calculator to find the square and square root of a number, and you can also use the four-figure table as well. Finally, we learned that a four-figure table is very useful when we are working with finding the square or square root of a decimal number. It's test time. Question 1. Find the square root of two whole number 8 over 196. Option A, plus or minus 6 over 14. Option B, plus or minus one whole number 3 over 7. Option C, plus or minus two whole numbers 7 over 10, or option D, plus or minus 20 over 7. So the first thing we do is to change our mixed fraction to an improper fraction. 2 whole number 8 over 196 will give us 400 over 196. Now we have to find the square root of 400 over 196. We will separate our square root to find the square root of 400 all over the square root of 196. Using our table, we'll see that the square root of 400 is plus or minus 20. And the square root of 196 is plus or minus 14. We can simplify this to give us plus or minus 10 over 7. If we change this to our mixed fraction, it will give us b, which is plus or minus 1 whole number 3 over 7. Question 2. Using the square root table given, what is the square root of 11.2? Option A, 3.19. Option B, 3.32. Option C, 3.35. Or option D, 3.49. The correct answer is C, 3.35. Now the number given to us was 11.2. Now using our table, the number before the decimal is 11. So we look for 11 on the left hand side of the table. The number after the decimal is 2. So we look for 2 at the top row of the table. Now we look for the number across 11 and under 2, which is 3.35. So that is why the square root of 11.2 is 3.35. This is where I leave you for today. I'm sure you now know how to use the square and square root tables to find the square and square root of numbers. Till we meet again. Bye-bye.